I am honored to have the opportunity to speak to you today about the topic of power and sample size for two-level factorial design using Minitab. This is a subject that holds great importance in the field of research and analysis. Use a two-level factorial design when each experiment factor has only two levels. Using a two-level factorial design allows researchers to efficiently study the impact of multiple factors at two levels each, helping to identify which factors are significant and how they interact with each other. Hypothesis testing is a critical concept in statistics, and it's important to understand the potential for type 1 and type 2 errors. Type 1 error occurs when we reject a true null hypothesis. In other words, we conclude that there is a significant effect or difference when there isn't one. This is also known as a false positive. In hypothesis testing, the value of alpha is predetermined and represents the probability of rejecting the null hypothesis when it is actually true. Therefore, 1 minus alpha represents the probability of not making a type 1 error, which is the probability of correctly accepting the null hypothesis. In statistical hypothesis testing, a type 2 error occurs when the null hypothesis is not rejected when it is false. This means that the test fails to detect a real effect or relationship that exists in the population. In statistical hypothesis testing, power refers to the probability of rejecting the null hypothesis when it is false. It is essentially the ability of a test to detect a true effect or difference. A high power indicates that the test is more likely to correctly identify the presence of an effect, while a low power suggests a higher likelihood of a false negative result. Power, in statistical terms, refers to the probability of rejecting a null hypothesis when it is false. In other words, it measures the ability of a statistical test to detect an effect, if the effect truly exists. The relationship between power and beta is inverse and complementary. As the power of a test increases, the probability of making a type 2 error, beta, decreases, and vice versa. This means that a test with high power has a low probability of making a type 2 error, while a test with low power has a high probability of making a type 2 error. The desirable power of test is at least 0.8.
When considering an experimental design, it is crucial to assess the sensitivity of the study by examining both power and sample size before data collection. Power, in this context, refers to the ability of the study to detect important differences or effects. It is essential to ensure that the power of the study is adequate to accurately identify these important differences. Inadequate power can lead to a failure to detect real effects, which can ultimately result in misleading conclusions. Assessing the sensitivity of an experimental design involves examining both power and sample size before data collection. Power analysis helps answer important questions such as determining the number of replicates needed to detect a meaningful difference in the response caused by the factor settings. It also allows us to evaluate whether the test was powerful enough to detect meaningful effects. Additionally, understanding the power of the test that was run is crucial for interpreting the results accurately. By considering these factors before conducting the experiment, researchers can ensure that the study is adequately powered to detect the effects of interest and minimize the risk of drawing erroneous conclusions. A power value of 0.9539 indicates that in a series of repeated experiments, there is a high likelihood, about 95.39%, of correctly rejecting the null hypothesis. This means that the experimental setup has a strong ability to detect real effects or differences when they exist. However, it is important to acknowledge that there is still a possibility, about 4.61%, of encountering sampling error, leading to a failure to reject the null hypothesis even when it is actually false. While this may seem concerning, it's worth noting that these odds are relatively small. Choosing a sample size, replicates. The objective of the study is to determine how many replicates of the design are necessary to achieve the power to detect effect sizes of 6 units or larger. For two-level full factorial designs, you can calculate number of replicates, effect, power values, and number of center points. You determine the values for any 3 of these parameters, then Minitab calculate the fourth. Choose stat, power and sample size, two-level factorial design. Complete the dialog box as shown below. Click OK. In the realm of experimental design, the number of replicates can significantly impact the ability to detect effect sizes. For instance, in a design with 2 replicates and 16 total runs, there is nearly an 83% chance to detect an effect size of 2 units and above. However, increasing the number of replicates to 3 and the total runs to 24 elevates the chance of detecting the same effect size to nearly 97%. The power curve is a visual representation of the relationship between statistical power and effect size for each combination of replicates. In this context, the engineer specified an effect size of 2, which is indicated by symbols on the curves. Adding blocks to the model. The objective of the study is whether adding blocks in model has any impact to the power of the test. Choose stat, power and sample size, 2-level factorial design. Complete the dialog box as shown below. Click OK. Click Design. In number of blocks, type 2. Click OK in each dialog box. The incorporation of blocking into a design has been found to have a slight impact on its power, reducing it from 0.830388 to 0.814604. When blocking is introduced, it can limit the variability within each block, which in turn reduces the overall variability in the experiment. This reduction in variability can lead to a decrease in the test's ability to detect differences or effects that may exist within the population. Estimating power with higher alpha. The objective of the study is to increase significance level to see the impact of power of the test. Choose stat, power and sample size, 2-level factorial design. Complete the dialog box as shown below. Click OK. Click Option. For significance level, enter 0.10. Click OK in each dialog box. The significance level in hypothesis testing plays a crucial role in determining the probability of making a type 1 error, which is the rejection of a true null hypothesis. By changing the significance level from 0.05 to 0.10, the power of the test increases from 0.830388 to 0.917623. This means that with a higher significance level, there is a greater probability of correctly rejecting a false null hypothesis, thus increasing the power of the test. However, it's important to note that increasing the significance level also increases the probability of making a type 1 error. Therefore, while a higher significance level can increase the power of the test, it also comes with an increased risk of incorrectly rejecting a true null hypothesis. Researchers must carefully consider the trade-off between the power of the test and the risk of type 1 error when deciding on the appropriate significance level for their hypothesis testing. The statistical test is crucial in determining its ability to detect an effect, assuming that the effect actually exists. There are 5 key factors that influence this power: the level of significance, alpha, beta, the expected size of the effect, the standard deviation of the hypothesized effect size, and the sample size. When considering a specific level of significance, alpha, increasing the sample size has the effect of decreasing beta, thereby increasing the power of the test. In order to simultaneously decrease both alpha and beta, the most effective approach is to increase the sample size. This adjustment can enhance the test's ability to identify real effects while maintaining a lower risk of incorrectly rejecting the null hypothesis. Therefore, careful consideration of these factors is essential in designing statistically robust experiments. Would you kindly consider liking and subscribing to our channel? Your support means a lot to us. Bye, see you next time.